Okay, so like the question said, we have vector OA to be small a, right? And we have vector OB to be small b, right? So this is our Cartesian plane, right? So there's a horizontal, there's a horizontal axis and there's a vertical axis, right? Okay, I think we have a fair idea. So in SHS, you will call this your x-axis and your y-axis, right? It doesn't really change anything. Now, we are going to assume that the vector OA lies on the x-axis and the vector OB lies on the what? On the y-axis. Now, it doesn't really matter which one you put on the horizontal axis or which one you put on the vertical axis. It won't really change your answer, by the way, right? So it means this vector what? OA, right? And this vector what? Vector OB. Now, if you remember, a vector is any quantity that has a direction and has what? A magnitude. So the vector you draw must have what? A direction and a magnitude. So my vector OA, this is what? This is a vector OA. So from here to here is what? Is my vector what? OA. So it is moving what? It's moving in this direction. That's the horizontal axis. And the magnitude of this vector is what? Is A. So it means my vector OA is actually A. It means it has magnitude A, but it's moving in this direction. So when I use the small letter A for this vector, it means I've indicated the direction of this particular vector and with the magnitude of A. And right, and my vector B, this is my vector B, is what? From here to here, and it's equal to a small b. So that's the magnitude of what? Of the vector OB, right? Now, this means that if I want 2a, this means that if I want, let's say, 2a like this, if I want 2a, this means that I want to have the vector OA plus another vector OA. So it means I'm moving the same direction, but what? With two of the magnitude that I have. So if my vector OA has the magnitude A, small a, and I want 2a, means I'll move the first a from here to here, then move forward another from here to here, right, which is also a. So I'm moving the same direction, but with the magnitude what? 2a. So it means this is going to be what? The vector what? 2a. If I want, let's say, minus a, if I want the vector minus a, right, it means I'm going to move in the opposite direction. So the direction is going to be what? From here, this O, to this, let's say, minus a, is what? Is my vector what? OA, but in the opposite direction. That's why I didn't bring the minus here, because it's in the opposite direction, right? The same applies to B. So it means from here to here is the vector what? OB with the magnitude B. I hope you guys understand. And this the direction is going. So if I, let's say, if I bring this over here, now this is what? The magnitude from here to here is the magnitude of this vector, of this vector B. So it's still the vector what? It's still the vector what? B, because it has the same magnitude. It has the same magnitude and the same what? Direction. You know, two vectors are equal when they have the same magnitude and direction. So this vector here is the same as this vector what? Over here. Right. I hope you guys are okay. Okay, so now we want to remember our goal is to draw the vector OC. OC is what? Is A plus B. Okay, now will you agree that my vector OC is actually this vector? So I'm saying this is my vector OC. Now OC is A plus B. What does it mean? It means that if I want OC, I have to move in the direction of the vector A at magnitude A and move in the direction of the vector B at magnitude B. So if I move from here to here and I move from here to here, it gives me what? The vector OC. So it means the same as me moving from what? Here to here. So my vector OC here is this particular vector. Me moving from what? Here to here, which is indicated as A plus B. So the magnitude of vector OC is what? Is A plus B. So if I want to indicate on the diagram the vector OC is actually this vector A plus B. I hope you guys understand. Now if I want the vector OD is giving us what? A minus B. A minus B means that I'll move in the direction of A at the magnitude A. Now move in the opposite direction of what? Of the vector B, but with the magnitude B. So the opposite direction of the vector B is what? Is here. So this, let's say, minus B, right? This, let's say, minus B. So this is what? The vector minus B. So if I want the vector OC, it means I will move from what? Here. It means I'll move from what? It's like I'll move from here to here, then from here to here. So it's the same as me moving from what? Right. So it means if I want to, so this is a vector OD. So the OD is what? So it means this vector is what? Actually A minus B, because I move from what? Here to here, and I move from what? Here to here. So if you draw your what's the name, small dashes, or your broken lines over here, this is the vector minus B. So I move from here to here and from here to here. So that's what the vector OD. I hope you guys are not confused. Right. So right now I've indicated the vector OC and the vector OD on the same diagram. Yeah. So you can take away these short dashes over here. So this is my vector OC and my vector OD. And the last part of the question says indicate the vector OE, which is what? A plus 2B. Now this is very easy. Now this is also saying that I'll move in my direction of A at the magnitude A, and in the direction of vector B 2 of its magnitude. So it means I'm going to move from here to here. Then I'll move from here to here, then under here to, let's say, here. So this is B, this is another B. So it means I'm moving from what? Here to here, right? So my final destination is from this vector here to this vector here. So this is my vector what? OE, which is what? A plus what? 2B. Now this vector and this vector are moving the same direction, but then it has a bigger magnitude of what? Of 2B. Do you understand? So that's how you indicate these vectors on the diagram. So this is a vector OE, this is a vector OB, this is a vector OC, this is a vector OD, and this is a vector what? OE. I hope this video makes sense to you guys.